Hi and welcome to this video on forces, in particular gravity. These are our objectives for today, so we're looking at how mass and weight interact as a result of gravity. So every object exerts a gravitational force on every other object. The force increases with mass and decreases with distance. Gravity holds planets and moons in orbit around larger bodies. So gravity is what means that the moon is attracted to the Earth. It's what means you're attracted to your pencil case. If we had a planet that was not held by the orbit of by the gravity of the sun, it would be zooming off into space. So the first thing you need to be able to do is draw force diagrams for problems involving gravity. So gravity always acts towards the center of the larger body. So in this case, all of these girls are being pulled in towards the center. You'll note they're not all being pulled down. It's always towards the center of the larger body. Okay, there is also a contact force acting up on them, but I haven't drawn that. So what's the difference between mass and weight? Mass is the amount of stuff that an item is made of, whilst weight is the effect of gravity on it. And what does that mean? Well, that means that if I'm on the planet Earth, the force of gravity is different than if I'm on, say, the moon. And if I go to the moon, which has a lower gravitational field strength, then I'm going to have less weight than I do on Earth. But unfortunately, because my mass hasn't changed, when I get back down to the Earth, my weight is exactly what it was before I left. So you need to be able to calculate your weight using the equation weight equals mass times gravitational field strength. And on Earth, the gravitational field strength is 10 newtons per kilogram. On the moon, it's 1.6. So if I have a mass of 70 kilograms, then on Earth, my weight is going to be 70 times 10, which gives me a weight of 700 newtons. By contrast, on the moon, my weight is going to be 1.6 times 70, or 70 times 1.6, which gives me a total weight of 112 newtons. Much less weight, but my mass is the same. There's still the same amount of atoms making up my body. So we need to look at what happens in different masses and different distances and explain unfamiliar observations. So if we were to go to Jupiter, well, Jupiter has much more mass than the Earth does. So as a result, the gravitational field strength is going to be much, much stronger. So because of that, my weight is going to be significantly heavier. In fact, it would be so significantly heavier that I would crush my own bones. What about if I fly on an aeroplane though? If I'm in an aeroplane, I'm at a greater distance from the Earth than if I'm on the ground. So because the distance between the two objects is greater, the gravitational field strength is slightly less, so the weight that I'm going to experience is going to be slightly less. It's not going to be significantly less though with the heights that airlines get up to. So my weight, I wouldn't notice a difference. So we can look at different planets to see how our weight would change depending on the gravitational field strength at the surface. So using the internet, I've come up with this table of different gravitational field strengths so we can work this out. So for Mercury, we're going to need to do 70 times 3.78, which works out my weight as 264.6 newtons. On Venus, the gravitational field strength is a bit more, 8.6. So my weight is 8.6 times 70, which is 602 newtons. On Earth, gravitational field strength is 9.78 times 70 is 684.6 newtons, so only slightly higher than on Venus. Mars has a much smaller gravitational field strength, so it's only 3.72 newtons per kilogram. Times that by 60 is going to give me a weight of 260.4 newtons. Jupiter, as I said earlier, much stronger gravitational field strength, 22.9 newtons per kilogram. So 22.9 times 70 gives me a weight of 1,603 newtons, which is why my body wouldn't cope very well with that. Saturn, actually quite similar to Earth, because even though it's very big, it's not very dense. So the gravitational field strength there is only 9.05, giving me a weight of 6.33.5 newtons. For Uranus, my weight is going to be calculated as 7.77 times 70, which gives us 543.9 newtons. And finally on Neptune, the last planet since Pluto got demoted, with its fairly high field strength of 11, is going to give me 770 newtons of weight.